Welcome. In this video I will show you how to solve an average speed problem that involves many different parts. So in this problem we have that Stacy travels by car from one city to another. She drives a half hour at 60 kilometers per hour, 0.75 hours at 80 kilometers per hour, and she spends 0.25 hours eating lunch and buying gas. Now there's two parts to this. The first thing we have to do is to determine the total distance traveled. And then the second part, letter B, we need to determine the average speed of her trip. So we need part A's answer in order to solve part B. Whenever solving problems, the first thing we want to do is draw a picture just to kind of help us remember what is going on in the problem so we can check whether or not the answer makes sense. So we have Stacy driving a car, and so we draw a car here. Next thing we want to do is we want to write down our givens, but we have really three sections of givens. We have the first part, the second part, and then the third part as well. And for each section, we are going to write down what is her time, what is her speed, and then what is her distance, which is what we're going to eventually calculate. So we have three different sections. So I'll label them as 1, 2, and 3. And then separate them as such. In the first part, it says that she drives a half hour at 60 kilometers per hour. Now the half hour tells me her time for that part of the trip. So under delta T, I'm going to write 0.5 hours. And the 60 kilometers per hour tells me her speed for that part of the trip. So I'm going to write 60 kilometers per hour. In the second part of the trip, it says that Stacy goes for 0.75 hours at 80 kilometers per hour. So again, the 0.75 tells us the time, and the 80 kilometers per hour tells us the speed. And then the final part of the trip, it says that she spends 0.25 hours eating lunch and buying gas. So the time is 0.25 hours. But the question is, what is her speed? Well, if she's eating lunch and buying gas, she is not moving during that time. And if she's not moving, that means that her speed is 0. In each section, what we're going to do is we're going to solve the distance, and then we're going to add them all up and solve for the total distance. So we need to get the distance of each part, add them up, and then get the total. To get the distance, we're going to use our equation. Our equation must have t, v, and x in it. So here's our equation over here. I'm just going to write that once, because I'm going to use the same equation in all three parts. In the first part, my v is 60. My x is unknown, so I'll leave that as a variable. And then my t is 0.5. I multiply each side by 0.5 to solve. So I multiply by 0.5 on each side. The 0.5s here cancel out, and I get that my x is 30. In this case, it would be kilometers, because in my v it is kilometers per hour. I'll do the same thing for the second part of the trip. My v is 80. My x is unknown, so that remains a variable. And my time is 0.75. I'm going to multiply each side by 0.75 to get rid of the 0.75 on this side. Here they cancel out. And I get that my x in this case comes out to be 60 kilometers. For the last part of the trip, my v is 0, my x is unknown, so I'll leave that as an x. and my t is 0.25. I multiply each side by 0.25. Here they cancel out, and I get that my x is 0. She has not moved in that third part of the trip. Now that I have all of my individual x's, I'm going to get the total distance that she traveled by adding all of them together. So my total distance is 30 plus 60 plus 0. So 30 plus 60 plus 0. And that comes out to be 90 kilometers. So during the entire trip, she has moved 90 kilometers. Now to get the average speed, we're going to use the same equation that we'd used before. The average speed is the distance divided by the time. But in this case, we're going to take the total distance, which we solved in part A, 90 kilometers, and we're going to divide by the total time. And to get the total time, we add 0.5 plus 0.75 plus 0.25. Okay? So we have our total distance of 90 divided by the total time. Total time is 0.5 plus 0.75 plus 0.25. We have to also include that part where she's not moving. That's included as well. That now becomes 90 divided by 1.5. If I take my 90 and divide by 1.5, I got 60. But I need my units as well. The units are going to be the same as what they've been the entire time, kilometers per hour. So to recap, for the first part, to find the total distance, you have to find the distance of each individual section. So break your problem into sections, and then add them together to get the total. For the second part, to find the average speed, you always take the total distance, which you just found in part A, and you have to divide by the total time, so you have to add up all the times from each section of the trip.